Have you ever pondered the complexity of decision-making? How about the simplicity of probability? Today, we delve into the world of artificial intelligence and machine learning, exploring two fascinating techniques, naive Bayes and decision tree. Dive into the realm of naive Bayes first, an algorithm that takes its roots from a 200-year-old theorem by Reverend Thomas Bayes. Naive Bayes is a classification technique based on Bayes' theorem with an assumption of independence among predictors. In simple terms, this model is naive because it assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. A naive Bayes classifier, for instance, might predict whether an email is spam or not. It considers all the words in the email independently, ignoring the order or the combination of words. It's simple, robust, and often outperforms more complex algorithms. Now, shift gears to the decision tree, another powerful machine learning technique. Picture a tree with branches and leaves. Each branch represents a choice between a number of alternatives, and each leaf represents a decision. Decision trees classify instances by sorting them down from the root to some leaf node, with the leaf node providing the classification of the instance. A decision tree, for example, could help predict whether a person will enjoy a new movie based on their past movie preferences. It's intuitive, easy to visualize, and can handle both numerical and categorical data. Now, imagine these two techniques in a head-to-head comparison. The battle between naive Bayes and decision tree begins. On one side, we have naive Bayes, simple and highly scalable. It handles large datasets with ease and performs well even with irrelevant features. However, its naive assumption often leads to oversimplification, making it less accurate when features are dependent on each other. On the other side stands the decision tree. It's transparent, easy to understand, and capable of handling complex relationships between features. Yet it's prone to overfitting, especially with noisy data, and can become overly complex with many branches, making it computationally expensive. In the end, the choice between naive Bayes and decision tree isn't a matter of which one is superior. It's about understanding the strengths and weaknesses of each and choosing the right tool for the task at hand. In the grand scheme of artificial intelligence and machine learning, both naive Bayes and decision tree have their rightful places. They each have unique strengths and weaknesses and are suited for different types of problems. The battle, therefore, is not about defeating one or the other, but about understanding their capabilities and applying them wisely in the quest to unlock the full potential of artificial intelligence.